The sky over Tokyo was perfectly clear. No storm clouds, no lightning, no turbulence warnings flashing on radar. Just blue emptiness stretching over Mount Fuji like a postcard. And yet, within minutes, a Boeing 707 would tear itself apart in midair. Not from a bomb, not from fire, not from pilot error, but from something invisible. On March 5, 1966, BOAC Flight 911 prepared for departure from Tokyo's Haneda Airport. The aircraft was a Boeing 707-436, one of the most advanced long-range jets of its time. It had crossed oceans. It had survived heavy weather. It was built to endure stress far beyond normal flight conditions. That morning, nothing suggested danger. The weather briefing showed strong winds over Japan, but skies remained mostly clear. To passengers boarding the aircraft, it was just another international flight, a routine leg from Tokyo to Hong Kong. Among the 113 people on board were business travelers, tourists, and crew accustomed to long-haul routes. The captain was experienced. The aircraft was fully serviceable. Fuel was loaded. Systems were checked. At 1:42 p.m. local time, Flight 911 began its takeoff roll. The Boeing accelerated smoothly down the runway. Engines roared. The nose lifted. Tokyo slowly fell away beneath them. Initially, the flight followed its standard departure route over Tokyo Bay. But shortly after takeoff, a request was made. Instead of taking the longer ocean route, the crew asked for a scenic path closer to Mount Fuji. The weather was clear enough for passengers to enjoy the view. Air traffic control approved the change. The decision seemed harmless. Mount Fuji stood magnificent in the distance, snow-covered, motionless, calm against the horizon. Yet meteorologists knew something most people did not. Strong westerly winds were flowing over the mountain at high speed. When air crosses a massive peak like Fuji, it does not simply pass over it. It can form powerful standing waves in the atmosphere. These waves can create violent vertical currents capable of ripping through the sky without warning. From the cockpit, however, everything still looked stable. No towering clouds, no storm systems, no obvious signs of danger. The Boeing climbed toward cruising altitude. Passengers lightly pressed their faces to the windows, cameras ready. Below them, Fuji appeared peaceful, but around the mountain, the air was anything but peaceful. At approximately 16,000 feet, the aircraft entered the zone. There was no thunderclap, no lightning strike, only a sudden violent force that hit the aircraft from below. The Boeing lurched upward with enormous acceleration, then dropped, then was thrown again. For a moment, it was as if the sky itself had become solid. What happened next unfolded in seconds. Seconds that would turn a calm afternoon flight into one of the most shocking aviation disasters of the 1960s. If you value deep investigations into aviation history, consider subscribing and leaving a like. Because what destroyed BOAC 911 was not visible on any radar screen. And it would force the aviation world to confront a terrifying truth about clear skies. The first impact came without warning. The aircraft was suddenly lifted by a powerful upward surge of air. Passengers felt their bodies press violently into their seats. Loose objects jumped, then the force reversed. The Boeing dropped sharply, as if the ground had disappeared beneath it. Mountain wave turbulence does not behave like ordinary bumps in the sky. It moves in massive, invisible oscillations. Updraft, downdraft, updraft again, each one stronger than the last. Inside the cockpit, instruments began to fluctuate. Airspeed shifted. Vertical speed indicators swung aggressively. The aircraft was no longer riding stable air. It was trapped inside a standing atmospheric wave. The first severe load pushed the structure close to its design limits. But the Boeing 707 was built strong. It had endured heavy weather before. What it had not endured was this level of vertical acceleration at cruising climb speed. Another violent updraft struck the aircraft. The nose pitched upward abruptly. The wings flexed under enormous stress. Then came the catastrophic moment. Witnesses on the ground later described seeing the aircraft shudder mid-air. Some saw a flash of debris separating from the wings. The vertical loads exceeded what the structure could tolerate. The right wing failed first. Metal fatigue was not the cause. Explosion was not the cause. The wing simply tore away under extreme aerodynamic stress. With one wing compromised, the aircraft rolled violently. Moments later, the remaining wing structure fractured. The fuselage began to break apart, sections separated in the air, the tail assembly detached. The aircraft disintegrated thousands of feet above the slopes of Mount Fuji. There was no controlled descent, no emergency call transmitted, no final message. The entire sequence lasted seconds. Below, debris scattered across forests and rugged terrain. Residents near Fuji reported hearing a distant rumble, then silence. When search teams reached the impact zones, they found wreckage spread over a wide area. This was not a single impact crater, it was a mid-air breakup. All 124 people on board were killed instantly. At first, speculation ran wild. Some feared sabotage, others suspected structural weakness in the Boeing 707 design. But investigators quickly noticed something important. There were no burn marks consistent with explosion, no evidence of onboard fire, no signs of collision with another aircraft. The metal told a different story. The fractures showed overload failure, the kind that occurs when stress exceeds engineering tolerance in an instant. The aircraft had not aged into collapse. It had been forced beyond its limits. But how could clear skies generate forces strong enough to tear apart a modern jetliner? To answer that, investigators turned not to the aircraft itself, but to the mountain. Recovery teams reached the slopes of Mount Fuji within hours. The wreckage field immediately told investigators one critical fact. This aircraft had broken apart in the air. Large sections were scattered miles apart. The wings were found separated from the fuselage. The vertical stabilizer lay far from the main debris path. This pattern ruled out a controlled descent. It also ruled out a simple crash into terrain. Japanese authorities worked alongside British investigators. BOAC needed answers quickly. The Boeing 707 was the backbone of long-haul international travel. If structural weakness was involved, the consequences would be global. Engineers began examining fracture surfaces under magnification. They searched for signs of fatigue cracks. They searched for explosive residue. They searched for sabotage. None was found. The metal edges were jagged and stretched. This was classic overload failure, the kind that happens when a structure is subjected to forces beyond its maximum certified design load. Attention shifted to the flight path. Why was Flight 911 near Mount Fuji at all? Air traffic control recordings confirmed the crew had requested a visual routing. The skies were clear enough for sightseeing, but the meteorological reports painted a more complex picture. Upper-level winds over central Japan were extremely strong that day. At altitude, westerly winds exceeded 60 knots. When fast-moving air strikes a large mountain barrier, it does not simply spill over and continue peacefully. It begins to oscillate, like water flowing over a submerged rock in a river. These oscillations form what meteorologists call mountain waves. Under the right conditions, those waves can become severe. In extreme cases, they generate powerful vertical currents. Some updrafts can exceed 3,000 feet per minute. Downdrafts can be equally violent. But here is the most dangerous part. These waves are often invisible, no thunderheads, no towering cumulonimbus clouds, only clear air. Pilots refer to it as clear air turbulence. On that afternoon, Mount Fuji acted as a massive atmospheric trigger. Cold upper winds collided with the mountain's steep slopes. The air was forced upward rapidly. As it crested the peak, it plunged downward on the leeward side, then rose again, then fell again. Each oscillation grew in strength. This created a standing wave pattern stretching miles downwind. Flight 911 flew directly into that system. At climb speed, the Boeing was heavier and less tolerant to extreme vertical accelerations. Investigators calculated that the aircraft may have encountered forces exceeding 5 Gs. That is far beyond what a commercial jet is designed to endure in routine operations. The first upward surge stressed the wings dramatically. The second surge compounded the stress. Then the downward motion added negative load forces. The airframe was being whipped vertically in rapid succession. Under such oscillation, structural loads multiply quickly. The wings flexed upward, then downward, then upward again. Metal has limits. Even the strongest aluminum alloy cannot withstand unlimited cyclical overload. The right wing root reached its breaking threshold. Once that structural integrity was compromised, the remaining structure had no chance. The breakup sequence was inevitable from that point forward. Investigators later concluded that the aircraft encountered one of the most severe mountain wave events ever recorded in Japan. The tragedy was not caused by mechanical defect. It was not caused by poor maintenance. It was not caused by reckless flying. It was caused by a rare combination of meteorological intensity and unfortunate positioning. The mountain did not move. The sky did not darken. But the air itself became violent enough to destroy a jetliner. And that realization forced aviation authorities to confront a chilling truth. Sometimes the most dangerous storms are the ones you cannot see. The official investigation reached a conclusion that was both precise and unsettling. BOAC Flight 911 was destroyed by severe mountain wave turbulence generated by strong winds over Mount Fuji. There was no explosion. There was no structural defect. There was no evidence of pilot misjudgment beyond a routing decision that seemed harmless at the time. The aircraft simply encountered atmospheric forces beyond its certified structural limits. That is what makes this disaster so disturbing. Nothing looked dangerous. The sky was blue. Visibility stretched for miles. Passengers were likely admiring the iconic snow-covered peak moments before the breakup. Yet high above the mountain, invisible standing waves were forming in the airflow. When fast-moving wind crosses a sharp elevation like Fuji, the air begins to oscillate vertically. These oscillations can extend far downwind, forming powerful updrafts and downdrafts stacked like ripples in the sky. In extreme cases, vertical accelerations can exceed what even large jetliners are designed to withstand. Flight 911 entered that system at climb speed, where aerodynamic loads are already significant. The aircraft was lifted violently, then forced downward, then lifted again. Each motion amplified the stress on the wings. Within seconds, structural tolerance was exceeded. After the tragedy, aviation authorities began reassessing how mountain wave activity was forecast and communicated. Meteorological monitoring improved. Flight planning near mountainous terrain became more cautious during strong upper-level wind conditions. Pilot training began emphasizing the danger of clear air turbulence near major mountain ranges. The lesson was clear. Clear skies do not guarantee safe air. Some of the most violent forces in aviation are completely invisible. Mount Fuji remains calm and symmetrical today, a symbol of beauty and balance. But on March 5, 1966, it reshaped the atmosphere in a way no one on board could see. And in less than a minute, a modern jetliner was reduced to fragments in a perfectly blue sky.